Okay, so this lesson is on factoring polynomials. So the learning goal is actually not to factor polynomials, it's actually to learn how to simplify rational expressions. But to do that, we're going to need to factor linear quadratic expressions and simple complex trinomials and difference of squares, just to write them differently. Okay, this question here is basically just saying, like, if you had a 3x squared, you don't really care what the middle term is, but you have a 4 on the end, what kind of binomials could you get to multiply? And the key here is so that we can do like a trial and error method of factoring. So we know that it has to be like 3x and x. Like, there's no other choice. If you don't do 3x times x, you're not going to get 3x squared. And then the other numbers have to multiply to 4. And so we're just going to assume that, like, we do not use decimals, like we're only using whole numbers. So that has to be true. And then the other ones have to multiply to 4. So 2 and 2 will work. You have to get positive 4. So there's a bunch of ways to do it, you notice. And there's, depending on what the middle term is, we'll know if, like, this is the correct way. And so the big thing is you just want to be comfortable with the fact that, like, 3x times x will always give you 3x squared, and these two numbers always multiply to 4, so that we don't try anything else. Those are the only numbers we're trying. And then the middle term will tell us what we actually need. So first, what is factoring? So I also asked the question, like, when was the first time you did factoring? And if you think like grade 10, when we did quadratics, it was actually way before that. Factoring is just writing a number as a product of two other numbers. So what multiplies to 48? By factoring it, like, you're basically saying it equals 24 times 2. That's a product of two other numbers. It also equals 12 times 2 times 2. It also equals 4 times 3 times 2 times 2. And there's other things that it'll equal as well. But by thinking about it like this allows us to remind us that we can check things as well by saying, well, we're saying it's equal. So that's a big idea, is like making sure that, like, when you say it's equal, it's actually equal. But 4 times 3 times 2 times 2, we can check to make sure they equal 48. So some common factoring questions first. Again, we're actually asking you the question, like, to write this expression. It's one expression. Write it as a product of two expressions. And so if you realize that there's a 2 in all of these, you can say that it's a 2 times something. And so the question is, what 2 times what will give you this? And so it's 2x squared. What multiplied by 2 will give you 4x, positive 2x. And what multiplied by 2 will give you negative 12, so negative 6. And we can expand it back out to check to make sure it works, and make sure that we're getting 2x squared plus 4x minus 6. The next one, what number goes into each term? So again, we're asked the question, like, what can we take out? Like, how do we write this as a product of other things? And so we can multiply 5y squared by something to give us this. If you just take out the 5 at first, then you're still going to have a y squared. And so what you're left with is, ask the question, 5y squared times what will give you 5y cubed? So it's y. And 5y squared times what will give you 15y squared? It's plus 3. And so this is like factoring. It's writing an expression as a product of 2 other or 3 other expressions. And again, we can check just to make sure. When you expand it back out, you're getting the right answer. When you say equals, they have to actually be equals. This one is really just to like expose you to the idea that, like, your common factor might be like a binomial. And so what's common in each term? It's the x minus 3. If you bring the x minus 3 out, you ask yourself, x minus 3 times what gives you 4x times x minus 3? And it's 4x. And x minus 3 times what gives you 3 times x minus 3? And it's got to be plus 3. And we can check by taking the whole thing, x minus 3, and expanding it in all at once. And that's what we're going to get. Some simple trinomials. So these guys, if we understand that two binomials multiplied together give us a trinomial, we know that we're looking for two brackets. And so we do put like x and x. That's the only way to get x squared. And then the number here we need to get plus 12. And so plus 12, we're not going to try numbers that don't multiply to 12. And so We can say add to -7 because like when we expand it, we're going to get -7x. And so it has to be -4 and -3. You can check it to make sure it works, just expanding it out. And really we don't have to check the first and the last number. We know that they would work. We just got to make sure the middle terms are -7. And the next one, you've got x and x. And it's multiplied together, we get x squared. And then two numbers that multiply to 20 are going to be 5 and 4. And so we get x plus 5 and x plus 4. And the complex trinomials, so first we look at them and ask, is there a common factor that can come out? Because if there is, then it might not be a complex trinomial. But certainly like 2 doesn't go into all of these. So we do have to go to the brackets. And they have to be 2x and x. There's no other way to do it. So now we're just asking the question, what times what will give us 35? And we're only going to try numbers that multiply to 35. And so your choices are 7 and 5 or 5 and 7. And so the question is just like, which one do you want to multiply the 2 by? If we multiply the 2 by the 7, we're going to get a 14. So just kind of like look and see. If we put the 7 here, it's going to multiply by the 2. And when we expand it, we're actually not going to get 17 in the middle. So that actually doesn't work. And so then we try to think like one step ahead and say, all right, I want to make sure I multiply the 5 by the 2 to get 10 and the 7 by the 1 to get another 7. And then when we expand it, we get the 17. The next one, it's got like, we can think about 6 and 1, and you can try 6 and 1. But because the 13 is in the middle, I'm actually thinking that like I want to multiply 5 by 3 to get kind of close to 15. So I try 3x and 2x, and if this doesn't work, I'll go back to 6 and 1. But I have a hunch that like I kind of want to be close to like 15. And so if I multiply the 5 by the 3, put the 5 here, it'll make sure I multiply by the 3. Then we get 15, and then subtract the 2x from the -1 and the 2x to get positive 13. And you get it on the first try. Sometimes you get lucky. Sometimes you're really thinking ahead. If you actually had to put the 5 here, you would have got 10 and then 3 here. And that you might think you can get 13. But because the signs have to be different to give you a -5, those numbers would have to be different. So 10 and 3 can only add to give 13, not subtract. Difference of squares, if you understand different, like x squared minus 9 is like a trinomial missing its middle term, it helps you understand that you're just going to two brackets again. So x times x has to be x squared, and then what times what gives you -9? It's -3 and +3. If the brackets are identical and when you expand it, the middle terms are actually going to cancel out. The next one, a difference of squares has to be a difference of squares. So these are both squares, x squared and 9. 8 and 50 aren't squares, but realize that 2 can come out, and you're left with 4x squared minus 25y squared. And then you've got that consistent like difference of squares. If you go to the brackets, we need 2x and 2x. And so it's got to be -5y and +5y. And again, because the brackets are the same, identical, but just opposite, we're going to get middle terms canceling out, and you can expand it and check. The last one, we actually look at the x minus 3 as the square part. And so we do 3x and 3x to get the 9x squared. But then we do minus x minus 3. So x minus 3 times x minus 3 gives you the x minus 3 squared. One's a minus, one's a plus. Then we just combine like terms inside the bracket. That question, like, it's just kind of exposed you to this idea of like you can have a binomial as one of the terms. It's still a difference of squares. If you actually expand this out and simplify it, you can factor as a complex trinomial. But like this is a lot like better, like a lot more efficient method. And there's some practice.